Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guests are from Nvidia. We have Roy Kim, who's the Senior Product Manager, and Andy Walsh, who is Director of Marketing for the Tesla products. Welcome to the show, guys.
Well, thank you, Rich.
So, Roy, I guess we'll start with you. I understand that you have some slides for us. You want to go through those?
So I'll just get started. This is an exciting announcement for us, and I'll keep it short and sweet. But if you go to slide number 2, we'll talk about four news. I'll introduce our what we call the 512 core Fermi, or I like to think of it as the perfect Fermi, the Fermi chip that everyone has been waiting for, and I'll talk about how that's impacted our OEM partnerships, in particular with HP and some of the benchmarks. Okay, so let's go to slide number 3. So there it is. That's the Tesla M2090. It has 512 cores. It has a 665 gigaflops of double precision peak performance. It has higher core clocks, higher memory clocks, so the memory bandwidth is higher too. What's really exciting about this is the impact that it has with our key market segments and our customers. And that's what you see on your right. You'll see there's 5 different market segments that we outlined. Each one of those are very, very important to us. Supercomputing, obviously, a lot of our revenues come from there. Oil and gas is the other vertical that have some significant customer base in. And in each one of those market segments, I outlined some of the key codes. And those key codes get tremendous speed ups with M2090 versus our current shipping M2070, 20 to 30% speed up. So that's really, really exciting for our customer base. Okay, so in slide number 4, this is just a spec sheet in some sense. Compared to the M2070, it's the same Fermi chip based on a slightly tweaked process. So it's the same 40 nanometer process, so it's slightly tweaked. And what we wanted to do was extract better power performance. So with that tweaked process from our partner, we were able to get significantly lower power. And so even with 512 cores in the M2090, we keep it under the same power level envelope of 225 watts. Higher core clock, a higher memory bandwidth, so 178 gigabytes per second versus 150. Single precision peak perf is 1.3 teraflops, right? So almost a 30% increase in performance versus the M2070. The memory size stays the same at 6 gigabytes. So what that means is that our customers, both end customers and our OEMs, can really enjoy this shattering performance on a new GPU and new system. So HP has announced a new server that has a tremendous density for GPUs. So their ProLiant SL390G7 has 8 Tesla M2090s with 2 CPUs in a half-width 4U dimension. So you can imagine that you could put this side by side and get 16 GPUs and 4 CPUs in a 4U chassis or dimension. So if you put that in a rack, that's about 100 teraflops of peak double precision performance in just a rack. It's quite amazing to me because just a couple of years ago, there was really just maybe a couple of OEMs that we worked with. Since then, just forward 2 years later, we have OEMs, global OEMs like HP, who are designing their servers around GPUs. Right? That's just, in my mind, that's mind-boggling. What they've done is they wanted to create a system that extracts the best out of Tesla GPUs, because they've heard from their customers that this is the configuration that they're looking for. 8 GPUs and then 2 CPUs. So one of the things that in conversation with HP that they have with customers, what they found generally speaking is that that CPUs don't really scale well, but GPUs do. And what they found is the optimal point is about 1 core to 1 GPU. So if these were 2 quad cores, this is a perfect configuration, right? If these were 6-core Westmers, then we could have used about 4 more GPUs in it. But this is really getting close to the ideal CPU to GPU ratio that the customers are asking for. All right, so in the next slide number 6, this is the other exciting news that we wanted to talk about in conjunction with the Tesla M2090. Just in the previous GTC announcement, we talked about how we shatter the world record of Amber performance. Right? Previous to GPUs, on Jack benchmark, the performance world record performance was 46 nanoseconds per day on 192 quad-core CPUs. At GTC, we talked about how 8 M2050s got 52 nanoseconds per day. And now with M2090s, you could get 69 nanoseconds per day with 4 M2090s. Right? So that's really a tremendous improvement just in one generation. Not even within the same generation of GPUs. The way that we like to talk about this, though, is that while this is great that we can outperform a supercomputer with just a single server with 4 GPUs, the way that we like to think about it is that M2090s empower every Amber researcher out there, from small research shops to large universities, who have a hard time getting access to supercomputers, right? They need to write a grant proposal and all that to get an access. In this case, they're probably in their small cluster running about 5 nanoseconds to about 10 nanoseconds per day, which is significantly small compared to what they can actually do. And with GPU-based servers, or just even one GPU server with 4, one U with 4 GPUs in it, let's say, or the HP server with 8 GPUs, you could get significantly better performance than even a supercomputer. And this is affordable for any researcher, and that's the great news that we want to share with M2090s. So going on to slide number 8, we really like this slide because it shows again, going back to where GPU computing was a few years ago, just 3 years ago when CUDA just started, to now. No one could have guessed just how far CUDA would come in terms of the penetration and in ISVs. And the ISVs I list here are some of the mainstream ISVs, the high volume ones that are the premier within that space. So in molecular dynamics, Amber, NAMD, GROMACS, these are household names for these scientists in that space. Earth Sciences, WRF, right? WRF is one of the key codes there. Engineering simulation we talked about, ANSYS and Simulia. There's MATLAB and Mathematica. These are all codes that just within the last few years have come out and supported CUDA and implemented CUDA in their software package. And they heard from their customers that this is the way of the future in terms of parallel technologies. And we're really excited about the kind of momentum that we're having in this space. We have a lot more apps coming out in the future, and so this is extremely exciting for us. I'm going to just end with slide number 9. Some of the questions that we get is GPU computing is interesting, but do you really have customers in the in mission-critical applications, right, the ones who really care about the reliability and all that, and the answer is really loud and clear, yes. If you look at this list, we have customers like Chevron and Petrobras in oil and gas who have to simulate, for example, with large amounts of data, where to drill within, let's say, the Gulf of Mexico. And just a slight error in data can cost millions and millions of dollars, right? And they've adopted GPU computing because it gives them a competitive advantage over in their space. And I could go on and talk about the other customers, but these are just some of the customers that have with open arms adopted GPU computing for competitive advantageness. So I think that's it for me. So I'll just, Rich, do you have any questions?
I do. I think this might be an Andy Walsh question, but going back a couple of slides there, I noticed I pay attention to this marketing stuff, right? So you're calling the 2090 an HPC processor. Is that a new moniker for your products, or was I just not paying attention?
No, it's not a new moniker for our product. It's the world's fastest processor for HPC. Mm-hmm. And this is a limitation of our slide deck. We wanted to keep it light on the words, but no, this is not a new moniker.
Okay.
It's that we are not coining a new category. If that's your question.
Yeah, I was just thinking the IDC would have to spin up all kinds of new numbers and things. So, but I did want to talk a little bit about slide 9 and these customers, right? As far as who's doing this at scale, right? I mean, I can understand we've got lots of customers using these GPUs, plugging them into devices, but what kind of percentages are you seeing of people that are actually filling up racks full of these things and enjoying economies of scale and getting scaled performance?
That's actually a great question. So if you look at this, the list of industries that you see here: higher ed, government, life sciences, oil and gas. We have customers in each of these spaces that are deploying GPUs to scale. In fact, in oil and gas, you'll find that some of the data centers in that space are larger than some of the largest supercomputers in the world, and they're powered by GPUs. I can't get into more detail on that because that's a source of competitive advantage for them. But you can imagine that in life sciences, particularly in the one that overlaps with higher ed, Amber and AMD drive large deployments, and government is one of the largest revenue segments for us. Some of the things that drive their deployment, as you can imagine, are things like signal processing. They have a lot of data, especially from video, that they need to process, and video gets more dense. With every technology right now, with HD, there's so much more data to try to process and essentially identify things that they want to identify, such as bad guys, right? So these all require scale-out type of platforms. Does that answer your question?
Yes. Yeah, that's helpful. So I wanted to ask, it's almost mid-May now. Is the 2090, is the shipping?
We are shipping in May 17th is the date that we will start launching the product.
Okay.
So it's out there. It's ready to go.
Do you anticipate us seeing 2090s out there on the next top 500 list? Because that's getting pretty close to the deadline for submissions.
I'd rather not comment on that.
Okay.
But we would love to see M2090s on the top 500 list.
Sure. I mean, because as you know, the bar keeps raising every top 500 list, and a lot of these sites like to do refreshes.
Well, okay. M2090 is a great GPU for the top 500 list, right? Just within that same power platform envelope, you get so much more performance. And we all know that power is the limiting factor in these supercomputing sites.
Well, great. This sounds really good, and congratulations on that. And thank you for coming on the Rich Report today. Roy and Andy, appreciate it.
Thanks, Rich.
Our pleasure.
That's it for the Rich Report, folks. Stay tuned for more news and information on high-performance computing.